All right, folks, let's do number 31. All right. All right, guys, let's do number 4. Figure the total acceleration of a particle moving in a clockwise circle of radius 2.50 meters. Thankfully, I don't have to draw it because the picture's right there. At the certain instant of time, so it's going to be at this point at 30 degrees from whatever the heck let's just pretend that this is x equals 0 or whatever. I don't really care. The radial acceleration and the speed of the particle and its descent. So think about what's physically going on with this object. You have an object going into a circle, and it has a specific radius. And let's just say that that radius is constant. Let's say that the tangential speed is not constant because it's going to increase by a factor of whatever a tangential of that component is. So this object is going to increase its speed. It's going to increase its radial. Don't say that it's not, because you're a dumbass if you say that. The truth is it will. Because by definition, when it's going in a circle, A has to equal B squared over R. That's just like, that's a given, folks. But we are talking about the moment that this is in this position. All right, let's just solve it, whatever. So let's do part A. Find the radial acceleration. So this should be pretty straightforward. So notice that we are given the magnitude of A. A is going to be 15 meters per second square. And we're given this component. So let's say that A radial is going to be, this right here, is going to be the magnitude of A, which is going to be just A, cosine of theta, which theta is going to be 30 degrees. And that's it, really. It's just A cosine of 30 degrees. Wow, that was pretty straightforward. That wasn't even hard. So the magnitude of A is going to be 12.99 meters per second square. That's the A radial component. So let's do part B. Let's see what random questions they ask. Because the speed of the particle. The speed of the particle. All right. Well, we just found A radial. So the speed of the particle is going to be the square root of A radial times the radius. The radius specifically here is going to be 2.50 meters. So I'm going to store that in my TI-84 calculator because that's just the way I roll. So I'm going to take the square root of A cosine of theta, which is 13 meters per second square, times the radius. So the speed then is going to be 5.70 meters per second. And let's see its tangential acceleration. Well, to get the A tangential, all you have to do is look at the picture and know your trigonometry, folks. And you would quickly realize that this is going to be A sine of theta. So I'm just going to put A sine of theta. And the A tangential here is going to be 7.5 meters per second square. And I'll be honest for you folks, if you are looking at the solution manual to figure this problem out, then you really are a dumbass. I mean, I don't know what to say, folks. I mean, if you know your mathematics, you can figure this out very easily. This is not hard at all, folks. So I don't want our future engineers to be like idiots, and nobody wants that. So please, folks, invest in yourself. All right, bye.